With a good understanding of what the pH scale is and what it represents, now we need to kind of get into the math behind the creation of the pH scale and what it represents. Before I do, I want to point your attention to all these equations at the top in bold. We have about 6 of them. I do want to point out that some of them are here. We have this one here and this one here. These are the 2 that we will be using in this unit. Again, the first and the third we have already used in the previous unit, even though they are both under the solutions unit. But again, we have these 2 equations here, which we will be making use of. So I just want to make sure that you are aware that they are there. All right, let's get into this. So what we have again is we have this right here from the previous video. We have how to calculate pH. pH here is equal to the negative log of the H plus concentration. Now, whenever you see something like this, H plus or OH minus, anytime you see those brackets, that always means a concentration of something. It's kind of a shorthand way of representing that. What we also have here at the top of the screen is the pOH, excuse me, is equal to the negative log of the OH minus concentration. Again, these 2 here are basically the same thing, just one is for pH, one is for the pOH. So if we were given a concentration of H plus ions or a concentration of OH minus ions, we could then easily calculate the pH or pOH respectively by typing in the negative log of that number, and that will give us our pH or pOH. What we also have here is, again, what I showed you earlier, which is the pOH and the pH always add up to be 14. Then these 2 are basically the opposite. If we on the top one, if we have the H plus concentration, we do the negative log of that H plus concentration to equal the pH. To go in the opposite direction, if we know the pH here, if we do the inverse log or times 10 to the negative pH, then what we have, of course, would equal the H plus concentration. And again, these 2 here are opposites as well. If we know the pOH, we could do the inverse log of the negative pOH, and that equals OH. Now, if that doesn't mean a whole lot to you, don't worry, because we're about to go through it together. Excuse me. All right, so what we have here for number 1 is we are given an H plus concentration. So what we're going to do is this equation here, because we are looking for the pH. Now what I'm going to do is I'm going to type into my calculator, I'm going to type in the negative log of 1 times 10 to the negative 9. And that will equal my answer. So on my calculator, I type in the negative first, way down here, not minus, but the negative, which is located right here. Then the log, which is located right here underneath my second button. So I have negative log, it opens a parenthesis. So then I'm going to put in my H plus concentration, which is 1.00, second E for times 10, negative 9. Then I have to close my parentheses. If you don't close that parentheses, you'll get a syntax error. So again, what I have in my calculator is negative or minus, not minus, but negative log, open parentheses, 1.00 second E, the little e, negative 9. I close my parentheses, I hit equal, and what I get is 9. Okay, knowing that a pH of 9 would be a base, and it would be a relatively weak base, not as weak as 8, but it would definitely be on the weak side. In fact, it would be 10 times more basic than water. Why do I say, excuse me, 100 times more basic than water? Why do I say that? Because water is a pH of 7. If I have to go all the way to a pH of 9, that is a 10 times 10-fold increase, or 100-fold increase, 100 times more basic than water, or 100 times less acidic than water, however you want to look at that. All right, let's try the next one. So again, I'm going to type in, I have my H plus concentration, I'm going to type in negative log 1.00 second E negative 6. I'm going to close my parentheses, and I get a pH of 6. A pH of 6, of course, would be acidic and on the weak side, about as weak as you could get for an acid. Now, I do want to point out that your moles per liter is the same thing as molarity. So don't forget about that because, of course, molarity equals moles over liter. So that is the same thing. Don't let that throw you. Again, is basically a measurement of concentration. The next one, again, we have negative log. I'm going to type in my concentration here, which is 0.0100, close my parentheses, and I get 2. 2, again, would be an acid, and it would be a very strong acid. All right, for number 2 is basically the same thing as number 1, except we're looking at our pOH. So I'm going to do the same thing, negative log of 1.00 second E, negative 5. I'm going to close my parentheses, and I get a pOH of 5. Remember that pH plus pOH equals 14. So basically another way to say that is if I take, or let me say it this way, these must add up to be 14. So I know that 5 plus 9 gives me 14. So if the pH is 9, then that tells me that this is a base, a relatively weak base. Sorry about the interruption, guys. The next one, I'm going to type in negative log of my OH concentration, which is 1.00 second E, negative 4, and that would be 4. All right, so if the pOH is 4, that means the pH must be 10 because 4 plus 10 gives me 14. pH of 10 is a base. Again, it is 10 times more basic than this one, or 10 times less acidic than this one, again, depending on your perspective. The next one, we have lithium hydroxide, negative log of my concentration, 0.00100, close my parentheses, and I get a pOH of 3. That must be 11 because 3 plus 11 gives me 14. pH of 11 is a base. Again, this is 10 times less acidic, and this is 100 times less acidic than 9. Again, that is because it is a logarithmic scale. All right, moving on to number 3. What we have here is something a little different. So we know that the pH is 4. We're going to do the opposite. So what we're going to do is we're going to do the inverse log. And what that basically is we have a 10 raised to the negative 4.00 will equal my answer. Now, how to do that on the calculator? If you look on your calculator underneath the second button where my log is, if I hit second, then I get something that looks like this, 10 to the x. That's what you want. You may have to hit the second button first, and then right below it should be the 10 to the x button. So to type this in my calculator, what I'm going to do is I'm going to do second log, which again is the 10 to the x. And what I get on my calculator is a 10, then it shows a caret top and an open parentheses. I'm going to type in my concentration or my pH over here, 4.00, close my parentheses. I'm going to hit my equal sign. So 4.00, close parentheses, equals, and what I get is 1 times 10 to the negative 4. Okay, I'm gonna do the same thing. So I'm gonna go ahead and put my 10 to the x button, which is second log. I'm gonna type in my pH, which is 5.00, close my parentheses, and I get 1 to the negative, or 1 to the 5th. Oh, yeah, I didn't say negative, but sorry. I meant to type negative 5, and which gives me 10 to the negative 5th. Next one, again, I'm going to do the 10 to the x, negative pH, which is negative 7, and I get 1 times 10 to the negative 7. Are you guys starting to see a little pattern develop? I hope so. 10 to the x, and type in negative 0.00, close my parentheses. Yes, this will work. And what I get is 1 times 10 to the 0, which again is the same thing as 1. 10 to the negative, or 10 to the 0 is the same thing as 1. Or, that's supposed to be or. or just regular 1, okay? Now, again, if you guys notice a pattern, we have 4 becomes -4, 5 becomes -5, 7 becomes -7, and this one, 0, becomes -0 or 0, which is the same thing. 1 times 10 to the 0 is 1. So that's a pattern you guys need to notice. It's a little bit of a shorthand. That only works if these numbers are 1, and you'll see again when that is not the case. Getting a little bit ahead of myself. All right, to do the next one, again, we have our pH to pOH. So what I need to do here, again, I know that pH plus pOH always equals 14. Okay, we've already done that. So if pOH is 14, then pOH must be 4. Or excuse me, why did I say 4? I just wrote a 0 and I said 4. 0. If pH is 2, this must be 12. If pH is 4, this must be 10. And again, if pH is 1, this must be 13. You guys all understand that? Because of course, they have to equal 14. All right, now that I have that, I'm going to go ahead and find my OH concentration from my pOH. So again, I'm going to do basically what I did here. I'm going to do 10 and then raise it to my negative pOH using, again, the 10 to the X button or second log. So I'm going to go ahead and do my 10 to the X button. I'm going to put in my pOH, -0, close that, and I get a OH concentration of 1 times 10 to the 0, or, of course, that again is 1. The next thing I'm going to do is, let's see, 10 to the X, -12, close my parenthesis, and I get 1 times 10 to the -12. Again, this is not surprising. If this is 12, guess what? That's going to be 12. Can you predict the next one? You should be able to. 10 to the X to the -10, close my parentheses, and what a shocker, it is 1 times 10 to the -10, and you guessed it, this would be 1 times 10 to the -13. That is absolutely correct. Okay, so those are pretty straightforward. Again, what we did on number 1 and 2 is basically the opposite of what we did on 3 and 4, going from H+ concentration into pH, or for an OH concentration into pOH. That's number 1 and 2. For number 3 and 4, again, we were given a pH or pOH, and then had to find the H+ concentration or the OH minus, excuse me, OH minus concentration. I was right the first time, from the pOH. So for number 5 and 6, it's a little bit different. Again, our shortcut that we just kind of identified, that the exponent is just the negative of the pH, doesn't always hold true, unfortunately. And you'll see why here in just a second. So for number 5, what we have is the H+ concentration, and we're trying to convert that into a pH. So what we've done before is we're going to use the equation at the very beginning, which is negative log of the H+ concentration. So for the first one, it'd be 1.45 times 10 to the -9. So I'm going to pick up my calculator. I'm going to do negative log 1.45 second E -9, close my parentheses, and I get 8.8, yeah, or almost 9. 8.8, again, almost 9. Notice this is a 9 and this is almost 9, because again, this is almost a 1, but not quite. As we get further away from a 1, then that's going to change this further away from that. So let's go ahead and try that out. So we'll do negative log of 2.00 second E -6, close my parentheses, and I get 5.6. So that's not too bad. This one again would be basically 1.8 times 10 to the -2, or I'm just going to type it in as is, negative log 0.0180, and I get 1.74 for my pH. Now, of course, going back to the right column, 8.8 is a base, and it would be a pretty weak base. 5.6 is an acid, not terribly strong, on the weaker side. 1.74 is a very strong acid, very dangerous. All right, number 6 again is kind of the same thing, but going into the from the OH. So if my OH concentration is 2.50 times 10 to the negative 5, I would type in my negative log of 2.50 second E negative 5, close my parentheses, and I get a 4.6 here. 4.6, I'm going to go ahead and subtract that from 14. And what I get is 9.4, because remember, these two must add up to be 14. 9.4 gives me a base, a little bit on the weaker side, but not super weak. The next one, I have negative log of 4.50 second E negative 4. That gives me an pOH of 3. We'll call that 3. I know that 14 minus 3.3 gives me about 10.7. Again, that would be a base again. But it would be not quite, but 10 times more basic than the first one, but not quite that far. The next one, negative log 4.00 second E negative 2 parentheses. I get 1.4. Notice again, this is really starting to stray further and further away from this, because again, this is further from 1. All right, so if my pOH is 1.4, then this must be 12.6. That would be a base, and again, approximately 100 times more basic than 10.7. Because again, two numbers on the logarithmic pH scale is 10 times 10 or 100 times more basic, or 100 times less acidic. All right, the next one we have here is number 7 and 8. They are very similar, just like 5 and 6 are very similar. Number 7, we are given a pH, and we need to go into the H+ concentration. Again, unfortunately, they are not quite as easy as number 3 and 4, because, although we're going to do the same exact calculation, because again, these numbers are not quite as simplistic. So if I have my pH, what I'm going to do, of course, is my this here, my 10 to the X, or 10 to the negative pH, which is 4.15. So I'm going to do second log, which is my 10 to the X. I'm going to type in negative, and then 4.15, close my parentheses. And what I get is 7.08, I'm going to round that up, times 10 to the negative 5. Okay, so again, we could not have said that's 1 times 10 to the negative 4.15, because again, we're getting a little bit further away. So the next one is 10 to the X negative 5.35. Oops, I did not hit my parentheses and I got a syntax error. So let's try it again. 5.35 parentheses, and I get 2.24 times 10 to the negative 5. Let me just double check that, because I feel like I did that wrong. 5.35. Yeah, I did do that wrong. Sorry about that, everybody. That's a 4.47 times 10 to the negative 6. There we go. The next one is going to be 10 to the X negative 7.23, close my parentheses. It is 5.89 times 10 to the negative 8. Next one is going to be 10 to the X of negative 0. Close my parentheses, and I get 1 times 10 to the 0, or 1. Number 8 is basically the exact same thing, except we need to start in pH, go to pOH, and then find the OH concentration. So if my pH is 13.32, I'm just going to subtract that from 14. And what I get is 0.68. If I subtract 10.45 from 14, I get 3.55. If I subtract 2.65 from 14, I get 11.35. And subtract that from 14, and I get 9.44. Now that I know my pOHs, I just do exactly what I did on number 7. I'm going to type in my 10 to the x negative 0.68, close parentheses, and I get 2 point, or well, I have 2.12, let me try it again. 2.1 times 10 to the negative 1. That's basically the same thing as 0.21. I have mine in scientific notation on my calculator. Next one, 10 to the x of negative 3.55. And I get 2.8 times 10 to the negative 4. 10 to the x of 11.35. Oops. Negative 11.35. I made that mistake already once today. Is 4.4. I'm going to round that up to a 7 times 10 to a negative 12. And last but not least, we have 10 to the x negative 9.44. And what we get is a 3.63 times 10 to the negative 10. All right, so that's how you calculate the concentration of H plus ions and OH minus ions given a pH or pOH, and how to do the opposite, and how to determine if it's an acid or base. Notice whenever I asked or answered what type of solution it is, I always went from the pH. If you know the pOH, great. Convert that into pH and then use the pH scale. If you try to determine whether it's an acid or base based on the pOH, it's the opposite, and you're more likely to get confused. So whenever I answered the type of solution, I always just found the pH and then determine the type of solution just to keep it simple. I don't want to confuse myself, and nor do I want you guys to do the same.